Here we've got some pretty hefty rebar. These are T40 bars. They're L-shaped bars and they're actually 7 metres long in total, and they weigh around 92 kilograms. So they're way in excess of what's suitable for a one-man lift. Bit of a manual handling issue. Very difficult to manoeuvre on site. They have to be lifted in with machinery, and the bottom L section has to be slotted in underneath the mat in the pour.
What we've got here, this is a great idea. It avoids a lot of problems where you have to go up and over concrete walls. The designers have basically scheduled the reinforcements such that there's couplers in the kicker level which allow the verts to be put in afterwards. The tails on the lacers are 1 metre long, so you can just put a lacer straight through when you're finished. This allows us to basically leave a gap open through the wall during the construction period, allowing safe access. You don't have to go up and over the top.
We've got some guys compacting the structural fill, which is going to be underneath the next level slab. The problem we've got is the L bars, which are cast into the wall or into the base slab for the next level. They can't actually get underneath to compact that to the full height. So we will have an area there where the fill is going to be uncompacted for a small part. A way around that might have been using U-bars in the wall, so we could actually get right into the slab at the side there. From a safety point of view, obviously for the shuttering itself, if we were able to lift that directly in, tight to the wall, it's a lot easier for our guys. At the moment, the shuttering there, when the wall comes up, it's underneath the bars, it's very difficult for access.
Obviously it's best not to have deep excavations, but when you're working on an old works and you have to tie into existing levels, obviously deep excavations are needed. One of the issues we've got here is that the structure we've just poured can't be backfilled just yet. The walls need to have a top slab on it to basically make it structurally sound, which means this temporary works is going to have to stay on site for another couple of weeks. If the temporary works wasn't here, obviously we can level up straight to the wall, bring the ground levels down and have a fixed staircase up and over straight into the working area.
Okay, here you can see we've got a series of angles bolted to the wall. This is to support our precast permanent false work system. Above that we've got pull-out boxes for the starter bars for the actual soffit slab itself. By pouring the wall in a wanner, we've managed to limit the amount of working at height. We've managed to also keep this area open with leaving the soffit till later, so we can crane in all the pipe work for the pipe gallery below, so we're minimising manual handling. By using the precast soffit support system as well, we also minimise the amount of propping required from below, which keeps a clear open space for all the activities happening down here.
We've also got one major structure going in along this building here. Obviously with the walkway above us, the temporary works is going to be quite difficult, and obviously the existing services running between the two doesn't help. The original design allowed for a in situ concrete slab to go on top of this structure. What we've done is we've worked with the designers to allow us to put a fixed internal shutter into the design to allow us to actually build all the mechanical plant first, pipe work, etc., and then cast the slab on second.
What we've got here is a fairly complicated arrangement. You've got a pump station at the front, you've got a RAS lift chamber behind that, and then a mixing chamber all backing into the new aeration tank. It's proven very difficult to get safe access for the men, particularly as you have to leave space to get shutters and things in, and there's not a great deal of room to work once you're in there. This is a desludge chamber behind me. It's wedged into a very tight space. There's not a lot of room to get past for access or putting up the wall shutters and so on. Also, the chamber itself is very small inside. It's difficult to get men down safely.
A lot of elements on the plant. This is a particular one which is very hazardous, which is sludge press, duty standby. Initially we were going to do it live, one side of the plant running, one side down, work on one side. We've got all the elements of the electricity, the moving parts of one side of the press while you're working on the other, which is unhealthy, which is complicated permit wise. We've got rid of that by just tanking the sludge out basically, maybe 3-4 times a week. Basically the hazards have gone, because There's nothing live, it's clean, it's simple, and we've got rid of the hazards.
One of the things that was agreed early on with the design team was to bypass the works, taking away the risk of the contractor interfacing with the process plant. Some of the risks are damage to existing mechanical and electrical kit working during the process, also unknown services and routing of cables and pipe work is always a problem. Also obviously means the job gets done quicker.
This is one of our final settlement tanks. Normally there's a reinforced concrete launder channel that gets put in around the outside. Fortunately here, designers gone with GRP instead. The advantages are it's a lot lighter and you're exposing the guys to a lot less work at height. Basically it's a question of putting in brackets every couple of metres and lifting it into place.
Simple one, open mesh flooring, never in the scope of works to do anything with it, refurbishing the 2 presses. Now we're putting Durbar flooring because on construction, as well as operation and maintenance purposes, i.e. stripping pumps down or whatever, on maintenance, on construction, anything can fall through there, from a mobile phone to sharp objects, nuts, bolts, people walking underneath, no hard hats, could be fatal. So that's the stance on this one. It's been agreed now, new Durbar floor, away with the mesh.
There's a high voltage cable under here, which is obviously dangerous to cross. We've got 2 pipe crossings to make. Now the cable goes to that transformer behind me, that's getting relocated anyway, so while we're doing that we're going to take the high voltage line right out round, out of the way.